right, let's see how we do on this assignment with the tree diagrams and the general multiplication rule for conditional probability. Okay, so here we go. So here we had questions, and they were based on this Venn diagram here. And so here we have, so this was, remember that, given that. So out of the total English circle, so that is this total English circle, which had 39 in it. And then I wanted to know the intersection of the physics and the English. So that's this little football-shaped area right here with the 18 and the 10. That was the physics and English. So that's why that's 28 right there. Okay, next. So this says probability of math and English, given that you're in the physics circle. So that's out of the total physics circle. So what I had to do is, okay, get this total physics circle here. So out of that 48, hopefully I added correctly. Sometimes that's a questionable thing. So out of that 48, what proportion is the physics or math and English section? Well, that means if you are in the physics circle, but then I want to know the part that also is math and English, that's you being all three. So that's this little piece here, that 10. Okay, and then the last one here was a little bit more involved. So I think that's the one that I indicated here with the coloring. So math or physics is the pink section that I have highlighted. So out of this total math or physics, and hopefully I added that all correctly to be 63, what portion of that is the English as well? So that's the English in addition to math or physics. So that is this English intersection portion with the pink area. So that's the 36 on top. Okay? I want to make sure you had a really good, clear understanding of how to do that given that probabilities with those Venn diagrams. All right. So here we have a little bit more. You could have either made a two-way table yourself. So this one you had to do yourself. I prefer Venn diagrams. Now, if you're doing your two-way table, then you end up with these numbers here in the middle. And so here we go. So the probability that we have a good dancer, given that he is funny. So remember, let's talk the work that's needed to be required. And we can do that in both of these. The work that needs to be shown, this one already has the problem written. But here, the work that needs to be shown is this notation here, and then the fraction. So that would be the minimum that you would need to show work-wise. So given that you're funny, so that's the entire funny circle. The proportion that's the good dancer and funny section is that 5 out of that 31. And given that he's funny, probability he's funny, given that he's a good dancer. So that's given that he's a good dancer, so that's the denominator 23 and the 5 on top of the 23. If he is a good dancer, what's the probability he is not funny? Okay, so here we go on that. So again, given that he's a good dancer, so out of the 23 good dancer ones, which of those are not funny? And it's these 18 out of those 23 that are not funny. All right, and then if he's a good dancer, what's the probability that he is funny? So is that not the same, right? That is the same as this one, okay? Just worded in different ways. Probabilities, okay, yeah, worded in different ways. Okay. All right, then let's go on to the next one. And here we have just basic formulas, just making sure that you know this formula here is the probability of A given B. So that puts the total probability on the bottom, the intersection of A and B on top. So that is what I do. So the probability of B on the bottom, so the 0.4, and the A and the B on top. So I'm not going to go into these. These are really just filling in the formula. So hopefully, 0.8 on the bottom, A and B on top. This one has the A on the bottom, so the 0.45 on the bottom with the 0.3 on the top. All right, so check those. Hopefully you can just fill in formulas. Moving on. So now, here we have this situation here. And so first, let's go through when I'm reading this problem, what leads me to think, oh, this is a strategy. This is something I need to do with a tree diagram. So when I'm reading it, I can see that you making it to your grandma's house, is the probability that you get there is different based on which mode of transportation you used. See, so if you get to grandma's house 10% of the time, if you do the mule, 90% of the time if you use the Jeep, and only 1% of the time if you walk. So that means I have multiple conditional probabilities. So if you have multiple conditional probabilities, then you need to organize this with a tree diagram. So here's how that looked down here. You are here. Here is the rate at which you choose those modes of transportation. And depending on which mode of transportation you take, that changes the probability at which you get to grandmother's or don't get to grandma's. Okay? So when I organize that, that's what all's happening. Now, notice that this first one says, what's the probability that you walk and do not complete the trip? So that's not a given that. That's just a purely saying you walk and don't make it. So that's the 0.099. Okay. I probably should have shown what I multiplied together there. Next, what's the probability that you make it successfully to grandma's house? Okay. So that's going to be 3 different pieces to this. So I'm going to come, so that's going to be my, what does it say? I successfully make it. So that's going to be the mule and you make it, plus walking and you make it, plus the Jeep and you make it. So basically, overall, there's a 41.1% chance that I'm going to get to grandma's house on my journey. Now, the next question is given that problem. See, what's the probability that you took the mule given that you did not make it successfully to grandma's house? Okay, so this one is a little different than the part B, okay? Because part B is asking about successfully making it. So I need to figure out what's the not making it. So here is that. So the not making it on the mule, the not making it when you walk, and then the not making it with the Jeep, okay? So that's what this denominator is, the total ways in which you do not make it. And of those total ways, which portion of that was the mule way? And that was this. So that's why 0.45 is the numerator. Okay. Next, here we go. Ooh, this one was tricky. Okay. I really like this one. I mean, it was kind of tricky to put it in here, but in hindsight, I'm glad that I did. I could see this being an AP problem that might be like a number 6 free response. The number 6 free response questions on the AP are a bit more in depth. They are a bit more out of the box thinking. And so this one had a little bit of that out of the box thinking. So let's just go through it and see how you did. Now, number 8 was more basic. So you may, if you got bogged down in number 7, don't worry. This was an unusually tricky one. So here we go. Let's take a look. So we got some boxes. You're doing your Christmas shopping. They came to your porch. One box has one gift for your sister and 3 for your best friend. Okay, so see, I went ahead and I started off here. with my box 50-50 chance, because you're just going to randomly pick a box. And so you have a 50% chance of getting the first one, a 50% chance of getting the second one. All right. So now, if you pick this first box, you have one gift for your sister in it. So 1/4 of them is the first one you're going to pick. One gift for your sister. And the second one, or then there's 3 gifts for your best friend. Okay. If you randomly select the other one, it has 2 gifts for your sister and 1 for your best friend. So this one has 2 out of the 3 are for your sister. So when you reach in there, you get 2/3 of a chance it's your sister's and only 1/3 it's your best friend. So here's where it gets interesting. You randomly select one of the boxes and you take one of the gifts out. It's one of the gifts for your sister. Yay. Okay, so it's one of the gifts for your sister. So that right there in itself is telling me, given that this has happened or this has happened. So here's where we are so far. Now, based on that, if you pull out another gift from the same box, what's the probability that it's going to also be a gift for your sister? Okay, so look at this. This one, this box, in order to get another gift for your sister, then there's not one in there. So with this box, there's a 0% chance that you're going to get another one for your sister. Okay? But over here, this one, okay, so I have gotten the gift for my sister, first one. But now you pull that out and you need to get another one. How many gifts in there are for your sister? There's 2 gifts left, and 1/2 of the ones that are in there are for your sister. So in order for this to happen, you need, out of, so here is the question. Given that you pulled out one, okay, so given that you are in this situation or this situation, okay, so given that the first gift was for your sister, what's the probability that you get another gift for your sister? Well, this is the only way you can get another gift for your sister. This is not a way. So therefore, it's that 0.1665 over that total. So there's how we have that. That was very tricky. Took me a while to figure that one out. All right. Next, here we go. Number 8. So this is Donald throwing the football to Goofy or Pluto. And so I think that, again, it being caught was conditional, 2 different conditional probabilities. So if you have multiple conditional probabilities, then you are going to organize it with a tree. So here Donald throws the ball. 60% of the time he'll send it to Goofy, 40% of the time to Pluto. But Goofy is Goofy, so he only catches it 10%, so he drops it 90%. Pluto, however, catches it not 70%. He drops it that much. All right, so there's what we got going on. So overall, find the probability that it is dropped by either Goofy or Pluto. So that is this plus this. Okay, so that's how we had to do that. That 0.36 plus that 0.12. All right. Now, next it says, given that, or if a ball is dropped, so that is your, given that it is dropped, then what's the probability that Goofy is the one who dropped it? So that means I need to do, out of all of the ways it was dropped, what part of that is the Goofy part of it? So out of all of these ways it's dropped, the Goofy part of it is this one. So that's the numerator out of that denominator. So that's why we have that. So if it was dropped, it's 75% chance it was tried to be thrown to Goofy. All right, given that the pass is caught, so now I have to redo my denominator. So, interestingly enough, instead of redoing that and adding this plus this, why does this plus this not add up to 52%? So that's interesting. Wonder if I did something wrong there, because that adds up to 34%. Because, this is supposed to add up to 100%. So what did I do wrong? Got something wrong there. 0.6 times 0.1. Oh, I can't multiply. That's my problem. Darn it. I thought my only problem was I can't add or subtract. So I can tell here. Now, I'm going to go back and how to fix this. This was 0.54. Hello. So there we go. Now I can fix some things. So just real quickly, here we go. We'll go fix that. It's dropping it as 0.54 plus 0.12. Okay, so you can go back in here and you can fix that. What is that? 0.66. Okay, so out of this 0.66, the part that it was goofy was the 0.54. So you have to redo that. And then here, so now this makes sense, because if there's 66% of the time that it is dropped, then I can see here, then it's 66 dropped, then it's out of the 34% of the time that it's caught. Okay, so notice how I caught that mistake. So that was interesting, because I knew that all the drops and the catches had to add up to 100%. And so that's how I caught myself in that mistake. Okay, so I'll go ahead and I'll fix these numbers and I'll re-put the key online for you. But there you go. There is your conditional probability, and using the tree diagram as your strategy if you have multiple conditional probabilities.